The Airbus A380 is a true flying monster. A plane featuring 2 floors, private showers, and horizontal stabilizers in the tail that match the wing size of other planes. However, all indications suggest that future commercial planes will be smaller. Forget about flying cruises and similar things. When thinking about the future, better imagine something like this. Why the future Boeing 797 won't be what you imagine. How did Emirates manage to save Airbus with their most ambitious project? Why these people are running out of the plane without looking back, or why this plane bends the tips of its wings is what you're about to discover. An airline makes business by taking people from one place to another and uses planes to do so. Therefore, the only thing that will matter to the company is whether a plane will allow it to make money or not. Before aircraft existed, to cross the Atlantic you had to go by boat, taking more than 7 days. When airplanes appeared and gradually improved to be able to cross the Atlantic Ocean, the time was reduced to about 20 hours. Imagine, an airline offering this service would know that it would have many passengers willing to travel, because the other option was 7 days at sea. A few years later, jet engine planes appeared, which flew faster and also flew higher, where there was less air resistance because the density was much lower, which allowed the flight time to be reduced to about 10 hours back in the 50s. In the following decade, in the 60s, the time was reduced to about 6 hours with planes like the Boeing 747, and since then, more than 60 years ago, the time of the journeys has not decreased any further. It has remained around 6 hours. Although, let's make a small note to remember that at the end of the 60s, the Concorde appeared, a plane that was able to reduce the time to about 3 hours to cross the Atlantic. The thing is that when a plane flies above the speed of sound, its geometry should be radically different, thus it will fly below the speed of sound. Flying supersonic also leads to significant efficiency losses. In the early 60s, all airlines were convinced that the future would go towards supersonic planes, and that's why almost all major airlines placed orders for the Concorde. But a few years later, when the Concorde was already flying, it was proven to be a complete disaster, as discussed in the video linked in the corner. So yes, planes fly at the same speed as they did in the 60s, or even a little slower. When the Concorde retired, we could say that subsonic aviation won the battle. Planes like the DC-10 or the Boeing 707 conquered the skies. However, if you look at the DC-10, which has 3 engines, these types of planes are no longer common or have ceased to exist. This is because the first jet engines were not very reliable. Their failure rate was much higher than it is today. For this reason, initially planes were not allowed to be more than 60 minutes away from an alternate airport. This meant that if a plane wanted to make a route, it wouldn't take the shortest or most efficient route, but rather the route that always kept it less than 60 minutes from an airport. This was done because one of its engines could fail at any moment, and therefore, to ensure that they could make an emergency landing at an airport with the remaining engine, they always kept that margin. Planes can fly without issue using only one engine. The fact of always being less than 60 minutes away was because it was studied that it was very unlikely that both engines would fail in that 60-minute period. This made sense with planes that use piston engines, which have a much higher failure rate compared to turbine engines. To give you an idea, the FAA says that a turbine engine can have a failure every 375,000 flight hours. On the other hand, a piston engine would have a failure every 3,200 flight hours. That is, for every failure in a turbine engine, we could expect about 115 failures of a piston engine. That's why more freedoms began to be granted to twin-engine planes as long as they proved to be safe using turbine engines. This is known as Extended Range Twin-Engine Operational Performance Standards, which we already talked about in this other video on the channel. Thanks to Extended Range Twin-Engine Operational Performance Standards, planes could be up to 180 minutes away from an alternate airport. This would allow them to make much more efficient routes. But here's where the trick comes in. These 180-minute restrictions only applied to planes that had 2 engines. So many airlines thought it was better to buy planes that had 3 or 4 engines to be able to fly wherever they wanted without having so many restrictions. And that's how tri-engine planes were born. But of course, remember, the reason for having 3 or 4 engines was not so much for power needs, but for regulatory needs. So what manufacturers did was increase the size of the planes to match the power of carrying 3 or 4 engines. And that's how gradually planes began to get bigger and bigger. As years passed, technology advanced and engines grew increasingly reliable. So there came a time when planes with 2 engines no longer had so many restrictions and could practically make any flight. Today, the Boeing 787 has an extended range twin-engine operational performance standard certification of 330 minutes and the Airbus A 370 minutes. In both cases, you can practically do any route in the world with the only exception of flying over some areas near Antarctica. So as you can see, nowadays a plane with 2 engines can practically do any route. But of course, a plane with 4 engines, like for example the A380, can carry a lot of passengers, up to a total of 853 at most. At this point you might ask, why 853 passengers but not 854? Well, the limit of passengers for a plane is determined by a test that must be successfully performed. It consists of evacuating the plane in 90 seconds with half of the doors operational. The A380 successfully performed this test with 853 people, although there are really many doubts if everyone could get out in an emergency landing in 90 seconds because on test day, everyone knows what to do and which door to exit. It's different from a plane full of disoriented people, but for now, this is how the passenger capacity of a plane is certified when comparing planes. You shouldn't do it just because of how beautiful or ugly they are. For us, as aviation lovers, it does seem like an important factor, but airlines focus on 2 particular things: the range and the passenger capacity it can carry. This graph provides the best way to compare different long-haul planes. The x-axis shows the maximum flight distance, while the y-axis indicates the passenger capacity. Looking at the graph, in green we have the twin-engine planes, and in blue the 4-engine planes. The main difference between them is the number of passengers they can carry. Mind you, not the maximum distance they can travel. In fact, an A3500 or an A3380 can go further than the Boeing 747-8 or the Airbus A380. However, these last 2 can carry more people, but 4-engine commercial planes are destined to disappear just like the 3-engine ones already did. In the 90s, Airbus began designing the A380, a real 4-engine, 2-story monster. All this under the pretext of taking over the long-haul market. Market studies at that time indicated that planes should be getting bigger and bigger because air traffic would continue to grow for several decades. The most important airlines saw in this plane a new possibility because with booming air traffic they could meet all the demand, but with fewer planes. The first deliveries of this model began to be made to the airlines, and even though they could carry up to 853 people, all airlines included several premium classes on the planes. In fact, the upper floor is usually exclusively for business class, so it is normal for an Airbus A380 to be able to carry around 500 people. After the first few months of operation, a problem arose. The plane had too much capacity. It's true that for routes with high demand, this plane is tremendously useful, but the reality is that most routes don't have enough demand to move 500 people at once. So many flights began to be made with the plane partially empty, causing airlines not to generate the expected income or even lose money. Over the years, several orders for the A380 were canceled to be replaced by other planes. In addition, it must be taken into account that a plane with 4 engines consumes much more than one with 2, not to mention that it also requires a lot more personnel to have the planes ready and perform maintenance. For several years, the monster of the skies was saved thanks to Emirates, which has received a total of 123 of these planes. If it hadn't been for them, the project would have been a colossal failure. Airbus admits they haven't recouped the investment in the design and production. So now imagine the situation if Emirates had ordered about 30 planes, like all the other airlines, instead of the 123. It would have been a resounding failure. In this video, I explained the Emirates model, which clarifies why they required so many A380 sizes. Mind you, I don't want it to be misunderstood. From a market perspective, the A380 has been a failure, but from an engineering standpoint, it's a true marvel. Airbus has learned a lot from this project, and I'm sure it will benefit them in the future for other planes. Currently, it seems that commercial aviation will be covered by two types of planes, short haul and long haul. The first category includes the Boeing 458 miles, AX, the Airbus A320neo, and their variants. Among the long-haul planes, we will have the A330neo and A350 from Airbus, and the Boeing 787 and 777-10 from Boeing. I'm sorry to say that it seems that era where there was a brutal variety of planes has ended. For example, at the end of the 90s or the beginning of the 2000s, planes like the DC-10, MD-80, A300, Boeing 757, Boeing 767, among others, were flying. In fact, even though the A320 family is considered short range, the A321 XLR, a plane that Airbus is certifying right now, will be able to cross the Atlantic without a problem. After Airbus's heavy blow with the A380, they likely won't design such large planes again. In fact, they are opting for the exact opposite. A few years ago, they began working together with Bombardier to make the A220, a plane that we could consider small for very short routes. On the other hand, many people talk about the future Boeing 7997 plane, the only one left for Boeing to manufacture from the series. The internet has many memes about how huge this plane will be. Since 9 is the largest in the series, people assume the plane will be large. However, the reality is that the plane will likely be medium-sized, somewhere between the Boeing 458 miles, AX, and the 787. Airbus, with the A321 XLR, is set to dominate the market for small, long-range planes, ideal for daily flights between Europe and the US East Coast. Evidence suggests the Boeing 797 will closely resemble the A321 XLR to compete with Airbus in that market segment. But watch out, because despite the fact that small planes are very promising, as I just mentioned, Boeing has been working for years on a plane larger than its previous models. And this is the Boeing 777-10, a redesign of the old Boeing 777. And yes, you heard right, it's larger than the Boeing 787, in fact, quite a bit larger. But there is an explanation for this. We usually compare the A350 with the Boeing 787, but the truth is their capabilities are somewhat different. The Boeing 787 has a shorter range and can also carry fewer passengers. Combining this with the future disappearance of the Boeing 747, airlines, if they want a long-haul aircraft with capacity for many passengers, would turn to Airbus with the Airbus A3500-10000. And this is where the Boeing 777-10 comes in. Its version 9 will be the plane that can carry the most passengers of all, and its version 8 will have the most range. In this way, they make very good competition for the European giant. As of this video's recording date, the Boeing 777-10 has received over 400 orders despite mass production not yet starting. But on the other hand, the A3500-10000, which would be the direct competitor of the Boeing 777X8, has only received 299 orders since the year 2006, while its version A350-900 has received 923 orders. It makes sense. If airlines are looking for a plane that can go very far, they would simply choose the Boeing 777X8. The Boeing 777-10, which we haven't mentioned yet, is absolutely incredible. It will operate the GE9X engine, the largest in the world, which is almost 3.5 meters in diameter. And in addition to this, the plane has such a large wingspan that in order for the plane to comply with airport standards, it folds its wings at the tips. But beware, it only does this when it's rolling very slowly, because it has no aerodynamic functionality. It's just to take up less space when they're storing it at the airport. It seems that the Boeing 777 and the Airbus A350 are going to be the largest commercial airplanes for many decades, and the only reason Boeing has designed this new plane was to compete with Airbus. Otherwise, they would have focused on developing smaller planes. But do you know why the Boeing 777-10 has such a large wingspan? I'll tell you now, but let me first talk about my book, The Manual for Thinking Like an Aerospace Engineer, with which you can learn all the amazing things about aerospace engineering. The book is written by me, and I talk about things like this because the plane is more efficient the larger the wingspan it has. That's why the Boeing 777-10 has such a large wingspan. Airplane engines follow a similar principle. Larger engines are more efficient. Well, if you really want to know why this happens, it's explained in my book, which you can find on Amazon and you can buy from anywhere in the world in its digital version. Keep in mind that besides being an aerospace engineer, I'm a big geek, so I like finding answers to questions. Many thanks to the channel members for supporting me with this project. Consider contributing if you like my content. See you next time. See you later.